Hello, everyone. So today we are going to discuss preparation of alkanes, uh, and we will discuss that what are the different ways how we can get the alkanes. We have covered the naming of the alkanes. So this lecture, in fact, um, involved that how the alkanes can be prepared and what are the some reactions of the alkanes. So let's move. So, sources of alkanes, there could be the question that initially I started the preparation of alkane, and that I am just stating a title that is the sources of alkanes. So, the reason is this that the preparation means that how it's general, that how the alkanes can be prepared or how we can get the alkanes. Now, the interesting thing about this is that the alkanes are widely available in natural resources. And so there is no special need for synthesizing in lab. So rather, as they are widely present in our uh, different natural sources, so they are extracted and recovered from these natural sources. So let's see what are these natural major sources from which we can get that alkanes. First is the fossil fuels, natural gas. So I'm mentioning these three major, which largely contain alkanes and hydrocarbons there. So the first one is the fossil fuels, which named as natural gas. Second one is petroleum. Third one is coal. So one by one, we will discuss each natural source, and obviously from each natural source, we shouldn't assume and we shouldn't expect that instantly we will get that alkane. So definitely we have to go for some of the procedures and some of the steps to gain our a pure alkane product, because the alkane is a general term. So there could be the butane, there could be methane, there could be the hexane one. So how we can sort it out and how we can get these from this mixture, because all these are the mixtures. These are not the pure things from where we can get only the one kind of alkane. So the first source is the natural gas, and natural gas consists of approximately 90 to 95% methane. It's having 5 to 10% ethane, and a mixture of other relatively low boiling alkanes, chiefly propane, butane, and 2-methylpropane. So if you just look at this one, so you know, and you can tell me that the butane and 2-methylpropane are basically the constitutional isomers, which we have discussed in our previous lecture, because one is a branch, another one is an unbranched one, but their molecular formula is the same one. The current widespread use of ethylene as organic chemical industry's most important building block is largely the result of the ease with which ethane can be separated from natural gas and cracked into ethylene. So I will talk about the cracking as well. But firstly, I wanted to explain you that um, it is easier that we can get the ethane, and which can be then converted into the ethene. So cracking is basically a process whereby a saturated hydrocarbon can be converted into the unsaturated hydrocarbons at the elevated temperature. And here, if you just look at the equation, so this is showing that at this, we are having the 800 to 900 degree C temperature, and it's high enough. So obviously, when we heat it, the alkanes at that high temperature, so that breakdown, and there is the removal of the hydrogen, and that converts into the unsaturated one. So I wanted to mention you that you should go for some of the physical properties of the alkenes, and you can see any of the alkane chapter of organic chemistry. And once I have suggested you as the Brown and Foote. So you can go through, because you should know that what is the impact of the chain length on the boiling point density and the physical state of the alkanes one, and what could be the difference between the branched and the unbranched one, because that branching and unbranching has also impact on the boiling point. So I wanted you to go through this, because at the end of that chapter, I'll give you a quiz and an assignment, so just covering whole of these information and topics. So right now, you see, the heating the alkanes, saturated hydrocarbons at the elevated temperature, and then converting into the unsaturated hydrocarbon is basically the cracking process. So from the natural gas, when we have the different pure components, so then that can be, because this is a mixture, and that can be separated from the distillation, and we can just then convert the one product which we have extracted, and we refine from this, and we have gained from the natural gas, so that can be converted into the other useful product. So ethylene, you may know that this is one of the very um, important building block or the raw material for a lot of polymer industry and plastics. So this is the basic starting material from which a number of chemical reactions and chemical industries. Now the next one is petroleum. So petroleum is a thick, viscous liquid mixture of thousands of compounds. So that's why petroleum countries who have that resources, they have the high impact on the world economy, because they can have they have that natural reservoir or the resource from which they can isolate, and they can get the lot of useful hydrocarbons. So the interesting thing is this one, that about 90% of the organic raw material for the synthesis and manufacture of synthetic fiber, plastic, detergents, drugs, dyes, and a multitude of other products are getting from the petroleum along with natural gas. So, as the petroleum is dirty, you can say, or this is the unrefined mixture of thousands of compounds. So obviously, for the specialized purpose and for the synthesis, when we are requiring some kind of chemical or particular alkane, we can't use this mixture. So there is a need to refine it. There's a need to um, separate that mixture into the pure components, so we can utilize it into useful products. So there are the number of ways how we can get the useful products from the petroleum, and this is the job of any petroleum refining industry, to produce usable products. So what they do is, so there are a number of physical and chemical processes for this purpose, but generally they are categorized into the two kind of procedures which are conducted on the petroleum or the petrol mixture, to get the useful products. So the first one is the separation process. The second one is the reforming process. So firstly, the crude oil, the petroleum, uh, will get into, or the natural gas will get into the separation, and then there will be another step in which we can reform that extracted products, right? So the separation is basically the thing when you have the mixture, let's say A, B, C, these are the three ingredients which are mixed together. And first thing would be to utilize or to conduct any reaction with A or B or C. So what you will do is, firstly, you will separate these three components, and the different containers, and then you can utilize for their further process procedures. So the separation is which separate the complex mixture into various fractions. And the second thing is the reforming processes. In the reforming processes, let's say we get the A component. So this is something the chemical treatment of that A fraction. So we can modify, we can alter its molecular structure. So let's say from the saturated, we are converting into the unsaturated, from the unbranched, we are converting into the unbranched one, from the acyclic or the open chain, we are converting into the cyclic hydrocarbon. So these kind of chemical treatments or under certain reactions, these are the reforming processes. And we see, so for the refining industries, the most of the commonly used separation technique is the fractional distillation. So that's why we will just talk about and limit our discussion on the fractional distillation, because this is the more applicable and this is the utilized separation technique in the refining industries. So fractional distillation is basically um, the procedure for refining the petrol into its usable fractions. So what is happening in the fractional distillation is that the petroleum um, or the crude oil is basically the crude petroleum or the crude oil, we say, is distilled under the very high temperature around 370 to maximum 425 degree and separated into fractions. So each fraction contains a mixture of hydrocarbons that boils within a particular range and they further distill, so get the specific hydrocarbons which fall in that boiling point range. So if you just look at this figure, so this is basically the inlet for pouring the crude oil, and vapors are preheated. So this is a preheated gaseous phase which is just passed through this refining chamber. And now they are the different compartments. They all have the different temperature. So the heavier will be at the lower side because they have the more molecular weight and they are having high density, and the lighter will have to treat at the lower temperature, which are the more volatile one, and they are the lighter one. So here you can see from the upper side, the gases, the boiling point range is below 20. So here that fraction will be separated, which is at the 20 or the below 20 degrees C. Then eventually we are increasing the temperature, and at last, at very high temperature, we get the residue which called asphalt, right? And this is a very greasy and the very sticky and very viscous kind of semi-liquid kind of fraction of the petroleum. So this is the fractional distillation in which each component of the petroleum is fractionally distilled. And the distillation, just to revise us, that when you are separating a mixture of the soluble liquids at their different boiling points. So every chemical or substance has, every liquid has its own boiling point, so we can separate these under different compartments and different heating chambers, so we can extract that one. And these are is showing, this is just the refinery unit and one part of it. And the next is that the refinery is too a huge industry, so they are the collectors where they are collected, and further they will be distilled to get the different hydrocarbons. So let's say this is the gasoline and naphthas it called, and there is a 220 to 200 degrees C. So most of our normal lower molecular weight hydrocarbons or the alkanes, um, and the hydrocarbons. So they could be the aromatic one, there could be the alkenes, alkynes. So we can get under this bracket. So they will be further distilled off to get the specific hydrocarbons which is stored separately. Now the reforming processes, once we have separated the fractions of the petroleum, now the next step is the reforming process. So reforming process is a technique by which the molecular structure of a hydrocarbon is rearranged to alter its property. So in petroleum, this is something that is dealing the process with the process frequently applied to low quality gasoline stocks to improve their combustion characteristics. So means they are converting into the high octane grade. So you may know that now there is the octane when you are going to any of the petrol pumps and you want to fuel your car, so you know there is a high octane and there is the normal petrol. So the people who know about the high octane, that this is the anti-knocking and this is having the high combustion, so they prefer to use it, and that's why they are, this is the more expensive as compared to the normal, which is not as refined, because it has uh, the mixture and they have a low combustion rate. So the reforming is basically they are the two common reforming processes. One is the cracking and other one is the catalytic reforming. So cracking is we also have discussed in the natural gas source, that when the saturated hydrocarbons at very high elevated temperature, they convert it into the other form of the hydrocarbons and unsaturated compound by the liberation of the hydrogen. So this is called the cracking, or this is sometimes called the combustion as well. But the combustion, more specifically, this is about when there is an oxygen and that convert into the carbon dioxide and the water molecule. So now the next thing is the catalytic reforming. So catalytic reforming is the process in which the any of the alkane, by using the catalyst, is converted into another forms of the hydrocarbons. So that can prolong unless we go for or desired product which we want to form. So for example, we have taken the hexane, which is the saturated six-membered uh, carbon carbon chain alkane. So by using the catalyst, um, this has removed the hydrogen. So now this is converted into the cyclohexane. So here we can talk about another thing which I may cover in future lectures, that how you can name these cyclic alkanes. So you just have to add the prefix cyclo um, with the name of that carbon parent chain. So this is the hexane. Rather write the hexane, but now we were adding the prefix cyclo because now this is a closed ring and the closed structure. So whenever there is a two end which are meeting or joining, so definitely there is another carbon and carbon bond is established. So that's mean there is the one hydrogen from this side has removed and one hydrogen from this side has removed. So now this is converted to the cyclic one. Now the further processing of the cyclohexane in the presence of the catalyst, this can give you the benzene, which is the aromatic hydrocarbon. And now this has removed the five hydrogens, six hydrogen from each of that carbon, because now there is a double bond which has established between this cyclic, or you can say geometrically, this is the hexagon. So that has the triple double bonded structure. So that is the benzene. So now the third major source is the coal. And before discussing that how the coal is important as a raw material for gaining the important usable hydrocarbons, there is a thing that we should talk about, the synthesis gas. So synthesis gas is a mixture of carbon monoxide and hydrogen in varying proportion. So that is very important. So varying proportion means that there is no fixed proportion, that this will be always in a 1 molar and 1 molar hydrogen. That can vary depending on that what is the mean by which it is manufactured. Means either we are using the coal, um, and water, either we are using the methane with the partial oxygen. So let's say synthesis gas can be produced by passing the steam, which is mentioned as a water, right? Because the steam is again the water. So passing the steam over the hot coal, and this can also be produced by the reaction of the methane and under the controlled oxygen supply. So this is called the partial oxidation of methane with oxygen in the presence of catalyst. So now you see that this is a mixture of carbon monoxide and hydrogen. This is a mixture of carbon monoxide and the hydrogen. So they all call the mixture of carbon monoxide and hydrogen is called the synthesis gas. But their proportion varies, because now here this is a 1 mole of carbon monoxide because there is no numeral added in front of it, and this is the 1 mole of the hydrogen gas. But in case of this, we have the 1 mole of carbon monoxide, but we have the 2 mole of hydrogen, right? So that synthesis gas is a mixture of carbon monoxide and hydrogen in a varying proportion, and that proportion depends on the mean by which it is manufactured. Now, the two important organic compounds produced today almost exclusively from carbon monoxide and hydrogen are methanol and acetic acid. And you know, these are very commonly and largely available in your chemistry labs too. And obviously, methanol is one of the most common solvent, organic solvent. Also, this is a polar solvent and used in a lot of. I think there is new industry where they are not using methanol as such, unless they are just making a salt or something. So acetic acid is present in your kitchen too, and this is again very useful and largely usable um, chemical in the industries. So these both compounds can be produced, and they are nowadays they are largely produced on the with the help of the synthesis gas, means with the carbon monoxide and hydrogen. So for their synthesis, we use a different catalyst. So the reaction of the carbon monoxide with the hydrogen gas in the presence of specialized catalysts, we can get the methanol. And the further treatment of the methanol with the carbon monoxide, because now we need one more oxygen and there is one more carbon under the presence of the certain catalyst. So we will get the acetic acid. So from this, because that synthesis method of the methanol and acetic acid from the carbon monoxide and hydrogen gas has the well-established application in industry. And another aspect of this reaction is the environment, because the carbon monoxide, which is poisonous, and if you are utilizing and recycling this carbon monoxide and you are converting this into the useful products, so that is pretty good. So now, as this has established, so the scientists are looking forward that in the coming year, the scientists will be able to produce the number of other hydrocarbons just by the carbon monoxide and the hydrogen, that there is a need to work on the catalyst which can help for that synthesis for generating the other kind of hydrocarbons too. So now that was for today. Thank you so much.